Hi there and welcome back to Atomo Tutorials. Today what we're doing is expanding on the last video where we looked at moles, masses and the number of particles, as well as how to convert between them. We're going to apply what we've already covered to problems involving chemical equations. And so if we go straight into a question here, we're given a chemical equation showing magnesium reacting with oxygen, and we're told that 5 grams of magnesium reacts with oxygen. How many grams of magnesium oxide is then produced from this? Now the first thing we need to do is balance this equation, because it isn't balanced. We need to make sure that the numbers of each atom are the same on the left and right hand sides of the equation. And we can see that there are 2 oxygens on this left hand side due to the small 2 within its chemical formula, but there's only 1 oxygen on the right hand side. To balance this out, we put a 2 in front of the chemical formula of magnesium oxide on the right hand side, and now we have equal numbers of oxygen. But in doing this, we now have 2 magnesium atoms on the right hand side and only 1 magnesium on the left. So we put 2 next to magnesium. Now we've balanced out the numbers of oxygen atoms and the numbers of magnesium atoms, and this equation is fully balanced out. So what we're being told from the equation is that for every 2 magnesium atoms that react, we need 1 oxygen molecule, which in turn then gives us 2 magnesium oxides. And that's just like a ratio. So if we have 10 magnesiums, for example, we'll need 5 oxygen molecules. That's all it is. And this is where moles come in. We can say that 2 moles of magnesium are needed to react with 1 mole of oxygen molecules to produce 2 moles of magnesium oxide. That would be true. So in terms of the question, we're told that 5 grams of magnesium reacts. We need to work out how many moles of magnesium this is. If you've watched the last video, you should know how to do this. Using the formula, to get the number of moles, we divide the mass that we've been given, which is 5 grams, by the relative atomic mass of magnesium, or the molar mass, you could say, which is 24 grams, or 24. 5 divided by 24 is equal to 0.208 moles when rounded to 3 decimal places. So in other words, 0.208 moles of magnesium has reacted with oxygen. Now, I'd like you to remember back to when I said that the amount of each reactant or product in an equation like this is based on a ratio. In this case, 2:1:2. So 2 moles of magnesium reacts with 1 mole of oxygen, producing 2 moles of magnesium oxide. But what if 0.208 moles of magnesium reacted? Well, that would of course mean that half the amount of oxygen molecules reacted because of the ratio, which is 0.104. But we're not actually interested in oxygen. The question is focusing on magnesium oxide. We have the same number in front of magnesium as we do in front of magnesium oxide. This means however many moles of magnesium reacts, the same number of moles of magnesium oxide will be produced. 0.208 moles of magnesium reacting means 0.28 moles of magnesium oxide will be produced. Now we're in a position where we convert moles to mass, because that's what the question is asking us. To get this, we need to multiply the number of moles, which is 0.208, by the relative formula mass of magnesium oxide. And magnesium oxide is made up of 1 magnesium and 1 oxygen. (24 plus 16), that gives us 40. The relative formula mass of magnesium oxide is 40. 1 mole of magnesium oxide weighs 40 grams. So 0.208 moles, which is how much of magnesium oxide we have, when we calculate it, is equal to 8.32 grams. And that's our final answer. Now this next page is going to focus on something we know as limiting reagents. We apply it to reactants in chemical equations. So let's say we have two substances reacting. If one of these substances is used up in the reaction will stop. Even if the other reactant hasn't been used up. The reactant that is used up is known as the limiting reagent. So if I try and make this a bit easy to understand, we're given the equation for a reaction between hydrochloric acid and sodium hydroxide. We're told that 3 moles of the acid is mixed with 1 mole of sodium hydroxide. So we have 3 moles of HCl and 1 mole of NaOH. Because there is a 1-to-1 ratio for the reacting particles, 1 mole of acid will react with 1 mole of sodium hydroxide. But if this happens, all of the sodium hydroxide would be used up quite quickly. We only have 1 mole of sodium hydroxide compared to 3 moles of acid. So all the sodium hydroxide is used up and we would have 2 moles of acid which are left over effectively and have nothing to react with. Therefore, sodium hydroxide is the limiting reagent. And the amount of product formed is directly proportional to the amount of this limiting reagent. Only 1 mole of sodium hydroxide reacts. Therefore, only 1 mole each of sodium chloride and water can be produced. And it's known as the limiting reagent because it's only the amount of that reactant which is preventing more products from being formed, if that makes sense. If we increase the moles of hydroxide to 2 instead of 1, and then carried out the reaction again, we would then be able to produce 2 moles of each product. Whereas if we increase the number of moles of acid from 3 to 4, it wouldn't do anything because we already have an excess of that amount. So that's the pretty detailed explanation of it. But essentially, the limiting reagent is the reactant which is used up first. So we're going to finish off this video with a question that more or less covers what has been looked at so far. We're asked how many moles of calcium chloride are produced when 4.9 grams of calcium hydroxide reacts with an excess of hydrochloric acid. We're also given a balanced chemical equation for this reaction. And the question is very much like the first one we did. And there's a couple of things I'd like to point out before we start. You might be wondering what the question means when it says that 4.9 grams of calcium hydroxide reacts with an excess of hydrochloric acid. So if we think about a reaction, let's say we have 2 reactants, A and B. If A reacts with an excess of B, it means all of A has reacted because there is more than enough of B present for it to react with, if that makes sense. On the last page, we spoke about limiting reagents. For 2 reactants, a reaction like this, the one which is used up is the limiting reagent, and for the one which isn't used up, meaning the sum left over, we say that this reactant is an excess. So for this example, calcium hydroxide reacts with an excess of acid. This means that we can assume all 4.9 grams of calcium hydroxide has reacted, and there's nothing left over of it. Now remember, we're focused on the number of moles of calcium chloride being produced, because that's what the question asks us. To find this out, we need to work out the moles of calcium hydroxide that have reacted in the first place, and we do this by converting from mass to moles. And we have the equation here to help us with that. We divide the mass of the compound, which is 4.9 grams, by the compound's relative formula mass. Counting up the numbers of each atom, we have 1 calcium, giving us a relative atomic mass of 40, 2 oxygens, because we have 1 oxygen in this bracket, but we have 2 of these brackets as indicated by the small 2. 2 oxygens, that's 2 times 16, 32, and of course 2 hydrogens, that's 2. 40 plus 32 plus 2 is 74, and that's the relative atomic mass of calcium hydroxide. So 4.9 divided by 74 is equal to 0.066. So we know that this many moles of calcium hydroxide reacts. Because the balanced equation shows a 1-to-1 ratio between calcium hydroxide and calcium chloride, we also know that the moles of hydroxide that reacts will be the same as the moles of calcium chloride that are produced. And this number is, of course, 0.066. If we wanted to know the moles of water that are produced, we look at the ratio between calcium hydroxide and water. And we will see that it has a 1-to-2 ratio, and so 0.132 moles of water are produced. But we're not interested in water. 0.066 moles is our answer here. Now, if you wanted to test yourselves, you can work out the mass in grams of this product. Now, if you wanted to test yourselves, you could try and work out the mass in grams of this product which is formed. We know how many moles of calcium chloride we have, which is 0.066. I'm not going to go through it, but I will leave the answer and the working for you to see if you've done it correctly.